Hello, my name is Ida Matilda Slusher. I have worked in the field of early childhood, and this is a presentation on how important physics is in our lives. And I wanted to use this opportunity to see how it affects my life as an early educator and my travel. Our agenda is introduction, physics principles, scientific methods, hypotheses, tests and revisions, classical physics, Galileo, Newton, electricity, magnetism, and light, James Clerk Maxwell, Einstein's physics, quantum mechanics, and a comparison of Mandy's and my travel. If you are like me, when you think of the word physics, you think of either complicated equations or Sheldon Cooper. Until I took this class, the word physics terrified me, but I learned how the elements of physics are all around the early childhood classroom, our lives, and travel. I will discuss some of each slide about how I saw physics on my visit to Kentucky and in my classroom. Physics principles. Mass and energy, momentum, thermodynamics, gravity, quantum mechanics, and light are the physics principles that we learned about. There are many ways that children and teachers see these every day. One of the main ways is planning STEM activities. These elements can be seen in my first plane trip that I went to see my mother in Kentucky. We'll see children observe, question, hypothesize, guess, experiment, try different things, and get results every day. Children are always experimenting. They build in the block area by looking at the shapes of each block and figure out what and how to use them. When I went on my trip, I had a lot of questions. Watched videos on what to expect in a terminal and what the flight would look like. I made guesses about what size my bag would have to be to fit in the overhead compartment and experimented by following through with taking the flight. In the next couple of slides, we are going to talk about Galileo and Newton and how their work is seen in the classroom, everyday life of the early childhood educator, and how I saw it on the trip to see my family. Galileo worked with physics of motion, falling objects, sun-centered universe. These elements of objects traveling slowly up a ramp, but an object needs less force to speed down the same incline. We can see this element in watching children build ramps for their toy cars. We see some of the same experiments of this work with physics, falling objects in an infant's classroom, of the child dropping items off walkers and high chairs to explore the effects. I visualized this when I watched the plane land through the windows while I was waiting for my flight to be called. I watched as the plane slowed down and dropped the wheels. I also felt the effects inside the plane as it speeds up to enter the sky and when it began to fly. I felt the change of the speed and air pressure as the plane landed in Kentucky. Newton's experience with the falling apple on his head was not the inspiration for his work with gravity. He was sitting where he could see the apple tree and he watched the apple fall. In the early childhood classroom, we see Newton's work of inertia, force, mass, action, reaction, and light in the play and planned activities in the classroom. Children kick balls on the playground, which is an example of inertia, and force on a mass. They learn action and reaction in building with blocks. We use many other activities such as creating sun catchers to explore light. In my flight, I saw the following. I experienced inertia and how the plane took off and landed in a way the sounds and feel changed. I experienced force and mass through the gravity pulling the plane to the ground, the lift created by the engines keeping the plane in the air, thrust that creates speed to oppose drag that tried to slow the aircraft to speeds that would cause us to fall from the air. I experienced action and reaction. I sat in the middle, but felt the action of the thrust of the air being pushed backward, making the plane move. I could feel the change, the wings keeping us in the air by moving the air down past the wings. Electricity, like everything, is made up of atoms. Atoms are made with neutrons and electrons. The middle is a cluster of them together. There are protons that spin around the nucleus as the planets spin around the sun. Each proton has a positive charge and the electron has a negative charge. So the electrons orbit around the protons. A change of movement creates electricity. We use electricity in the classroom. However, when there is a weather outage or other event that takes the power, the school has a backup source that stores the sun's light to turn it into electricity to keep the lights and power on, the refrigerators to save the children's food, and the computer working. In my travels, electricity was everywhere. At both terminals, I saw televisions, charging stations, and outlets on every wall. On the plane, the lights were dimmed on on takeoff and to conserve energy for the flight. It was turned back on at the landing so that people could safely deboard. Magnetism are also created by the changes created by movement of charged electrons spinning in opposite directions. All magnets have both positive and negative fields. This is why only one side of a magnet will attract to the other. I see this when the children are playing with magnet tiles. They create houses, ramps, and robots by turning the objects until they find negative and positive sides to attach. In my flight, I experienced magnetism when placing my luggage in the X-ray belt and walking through the body scanner that uses millimeter waves or backscatter X-rays and metal detectors using magnetic fields to detect metal objects that may be a problem in flight. Light was thought to be particles for hundreds of years. Then was found that it is both waves and particles. Light changes to fit how it is being used. I see this in different activities that we do in the classroom. Children love to create shadows with their bodies, and they also like creating sun catchers by adding thin pieces of tissue on laminate pockets. These activities show lights in two different ways. The shadows are made from the light moving around the body, but the light moves through thin paper to create a beautiful image on the sun catchers. I experienced light in different ways in my trip. The sky was sunset when the flight started in Florida, but I only saw the lights of street lights and window lights when I landed in Kentucky. In the terminals, lights were at different strengths according to the need. Examples, storefronts and restaurants were bright colored with neon lighting. The waiting area has more soothing white lights to help people relax. James Clerk Maxwell began the theory that changing the electric fields means that electricity and magnetic force can travel at the same speed as light. This theory has been proven later by experiments. His work on electronic fields are at the root of air navigation. The airplane and control towers use these waves to communicate with each other and other crafts. It also detects any problems in the area so that the flight made from Florida to Kentucky could be made safely. Changes in cameras used in classrooms, homes, and travel. Cameras in the 16th century used a small hoe to bring the image to the back wall to create an upside-down image. The mirrors were added to turn the images upright years later. Then photographers used light to create a temporary image on leather. In the 19th and 20th centuries, brought handheld cameras, paper images, film, and digital cameras that use electronic charge, flash, and pixels that are instant. You can also charge these and Bluetooth them to home computers to be printed. I used a camera in my cell phone to take pictures in the terminal of different images. It was my first trip, so I had pictures out the windows of the airport, boarding the plane, and the different signs in the terminal. I also made sure to take photos of my family that I had not seen in years. Einstein showed that mass and energy are different forms of the same thing. If you ever read Dr. Seuss's children's book, The Snitches, you probably remember how the yellow bird-like characters in the story go from a machine to change back and forth between star-bellied snitches and plain-bellied snitches. The number of snitches remain constant throughout the story, but the ratio between plain and star-bellied one's changes. It's the same with energy and matter. The grand total remains constant, but energy regularly changes from form into matter and matter into energy. This equation cannot be measured in the trip because it would require us to travel at the speed of light. However, Einstein's work with relativity does show in travel by the fact that I should have aged a little slower than my husband on the ground in Florida. Recent studies say that frequent flyers actually age faster in very small nanoseconds. Quantum mechanics, also known as wave-particle duality, the smartphone that I used in the classroom and to take pictures of my families and enter my observations into an app, uses transistors that are a descendant of the study of quantum mechanics. From the minute I entered the airport, quantum mechanics have part of my experience. Surveillance is a part of quantum mechanics, along with the communications of captain to air control and the manufacturers of safer and faster engines. Remember Mandy and her trip versus my trip. So throughout the course, we learned that Mandy had her trip to Rome. We talked about force in her takeoff and landing, light in the sunset, and about the speed. We discussed time and how her age was different than by very little because of the speed of the plane. We learned how charging was possible through electricity. My favorite was learning about the effects on early childhood education. Because I visited my family traveling on an airplane, my experience was much like Mandy's. The difference is that we aged differently because the distance of the trips were different in length. She saw different terminals because she left the country. It was interesting to see how physics was a part of my career and my first trip on an aircraft. Thank you for the time you spent learning about physics and what it is in my life, my career, and my trip to Kentucky. And thank you for your patience. Video is difficult. These kind of assignments are difficult for me. But I'm glad that we learned it together. Thank you for your time.